Very good morning to all of you. Welcome to mathematics class of grade 8, and this is summary lecture of chapter number 12, exponents and powers. Dear children, in this summary lecture we will recall all the concepts of this chapter 12, exponents and powers, to have a better understanding of all the topics of this chapter. So let us see now topics to be discussed. These are the topics to be discussed in this summary lecture. First of all, we will have a look on the topic powers with negative exponents. Under this topic, I will be explaining you the difference between exponents and powers. After that, we will recall the laws of exponents. Then we will move to standard form, that is, we will revise how to convert small numbers into standard form, and then usual form we will talk about, and at the end of this lecture I will be discussing the homework solutions of the previous lecture. So let us move to first topic, that is powers with negative exponents. This is the first topic which we are going to discuss, that is powers with negative exponents. First of all, let us understand about powers. What are powers? Basically, multiplying many times or multiplication many times is powers. For example, if I am multiplying any number, say I am multiplying 3 5 times, it will be 3 into 3. I will be multiplying 3 5 times, so I will be writing like this. What is it equal to? 3 raised to the power 5. So this format is basically powers. Now in this format, 3 is the base and 5 is the exponent. Now this exponent, it can be positive, it can be negative, or it can be 0 also. In your previous class you must have studied about positive exponent, and now in this grade 8, in the previous lectures, you have come across the negative exponents and as well as 0 exponent. So let us see again. Let us see now about negative exponent, positive as well as 0 exponent. For example, if I am multiplying 10 2 times, what will it be equal to? It will be 10 into 10, that is equal to 100. Now, if I am dividing this 10 by 10, then it will be 10 raised to the power 1, that is, it will be 10, as I have divided this 100 by 10, so I will be getting 10. So I have divided this side also by 10. Similarly, if I will divide this again by 10, I will be getting 10 raised to the power 0 as 1. As I keep on continuing with the same pattern, I will be getting 10 raised to the power minus 1 is equal to 1 over 10. So dear children, we have concluded that a raised to the power minus m, in general form I can write as a raised to the power minus m is equal to 1 over a raised to the power m. So it means whenever I need to make the exponent positive, I need to take the reciprocal of this base. And exponent, as it was negative earlier, so it will be positive now. Here you can see the exponent is 0, that will be equal to 1. And if the exponent is negative, I need to take the reciprocal of the base and the exponent will be positive. So dear children, I hope you have understood about positive exponent, 0 exponent as well as negative exponent. And a raised to the power minus m, as I told you, it is equal to 1 over a raised to the power m. So where a is any non-zero integer and m is a positive integer. And there is one more point regarding a raised to the power minus m. there is one more point regarding this, which is a raised to the power minus m is the multiplicative inverse of a raised to the power m. The reason being, if I will multiply these two, I will be getting answer as 1. The base is same. This is one of the law of exponent. Base is same. In between multiplication sign is there. So powers will be added, or it will be equal to minus m plus m, that is equal to a raised to the power 0, that is equal to 1. So a raised to the power minus m is the multiplicative inverse of a raised to the power m. Coming to next topic of today's lecture, that is laws of exponents. The very first law is a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. Because base is same, multiplication sign is there, exponents will be added. Next law is a raised to the power m divided by a raised to the power n. What is it equal to? A raised to the power m minus m. Base is same and they are being divided, so exponents will be subtracted. The third law is a raised to the power m further exponent n, then it will be a raised to the power mn. These two will be multiplied. Then we have ab raised to the power m, that is equal to a raised to the power m into b raised to the power m. Here these two are different, bases are different, but the exponent is same. So it will be equal to a raised to the power m into b raised to the power n. After that we have a by b raised to the power m is equal to a raised to the power m over b raised to the power m. Then we have, in this what we have done, base is different, a over b raised to the power m, so it will be a raised to the power m, b raised to the power m. These are being divided. So after that we have a raised to the power 0 is equal to 1. This we have seen earlier, and this is one more is left, that is a raised to the power minus m is equal to 1 over a raised to the power m. This is a very important law which is mostly used in the questions, that first of all we need to make the exponent, if the exponent is negative we need to make it positive by taking the reciprocal of the base. Now let's look at this topic, that is standard form. What is basically this standard form? When a number is any number is being expressed as a decimal number multiplied by a power of 10. Like if I write like this, a number 5.98 into 10 raised to the power 10, or it can be any number. Then if I can, I am writing like this, 10 raised to the power minus 6, or it can be 1 decimal 275 into 10 raised to the power minus 5. It can be 3 decimal 5 into 10 raised to the power minus 5. All these are the standard form. What is this standard form? I am repeating it. In the standard form, or if a number can be expressed as a decimal number multiplied by a power of 10. Decimal number multiplied by a power of 10. Here it is decimal number multiplied by a power of 10. This type of form is known as standard form. All these are the examples of standard form. Now, numbers may be given to us in this manner, then we are supposed to convert those numbers. So let us see now few examples how to convert very small numbers from decimal notation to standard form. For example, If I need to convert this decimal number into standard form, how will I convert? This is the first example I am taking. It is 0.00058. Now this is a decimal number. I need to convert it into standard form. So when I am moving this decimal from left to right, I need to move this decimal till I get the first digit. So I am moving the decimal now. This is one step, 1, 2, 3 and 4. Here I will stop because I got a first digit, that is 5. So 5 decimal 8 into 10 raised to the power. How many digits I have moved? 1, 2, 3 and 4. So it will be 10 raised to the power minus 4. So what I have done, I have moved the decimal from left to right, and the number of places I have moved, I will be writing it as 10 raised to the power that number. That will be minus 4. When I am moving the decimal from left to right, exponent will be negative. Now let us take another example. The example is 405. It is 4 zeros now. Now here I need to take the decimal from this right hand side to left hand side. Here no decimal is present. So from right to left I need to move the decimal. So it will be 4 decimal till the last digit I need to move. So I am moving the decimal now. 1, 2, 3, 4, 5, 6. I will stop here. 4 decimal 05 into 10 raised to the power 6. 6 digits I have crossed, 6 steps I have taken. So 6 steps I have taken to reach 4. So it will be 10 raised to the power 6. It will be positive exponent. You can see the difference in these two examples. Here I am moving the decimal from left to right. So exponent will be negative. I am moving the decimal from right to left. So exponent will be positive. So this is very important to understand these two examples, to keep in mind, because these will help you to solve the questions of NCERT and other questions also you will be able to solve very easily. Next topic is usual form. Now we will learn how to convert the numbers from standard notation to this usual form, or usual decimal notation, or usual decimal form you can also say. Now again I am taking two examples. The very first example I am taking is, it is 3 into 10 raised to the power minus 5. So what is it equal to? It will be 3 divided by, as the exponent is negative, to make it positive I need to take the reciprocal of the base. Base is 10, so I am writing it in the denominator. So it will be 3 by 1, 2, 3, 4 and 5. So after decimal we should have 5 digits. So it will be 0 decimal 1, 2, 3, 4 and 5. So this will be the answer. If the exponent is negative, you are supposed to write like this, make it positive. Then after the decimal, the exponent of 10 should be the number of digits after the decimal. So this will be the first example. Second example I am taking as 4.5 into 10 raised to the power 4. Now here the exponent is positive. So 4.5 will be written as 45 over 10 into 10 raised to the power 4. Now this will cancel out 1 0 of this 10 raised to the power 4. So it will be equal to 45 into 10 raised to the power 3. So it will be equal to 45,000. So this is very simple. This will be the answer of this example. I hope you have understood all the cases of usual form as well as the standard form. Now I will be discussing the homework solutions of the previous lecture. I am solving first exercise 12.1, question number 7, first part. The first part says, simplify 25 into 10 raised to the power minus 4 divided by 5 raised to the power minus 3 into 10 into 10 raised to the power minus 8. Dear children, in this case, wherever you find negative exponent like here. So try to make these exponents positive by taking the base reciprocal of their bases. So it will be 25 into t raised to the power 8. I am shifting this in the numerator, so it will be positive exponent, into this 5 raised to the power 3 will be shifted in the numerator, so it will be positive, divided by this t raised to the power minus 4. When it will be shifted in the denominator, it will be t raised to the power 4 into 10. So I am explaining this step again. What I have done here, the exponent of t is negative. So to make it positive, I have shifted it in the denominator. Here it is already in the denominator and the exponent is negative. So I have shifted in the denominator and the exponent will be positive. Same is the case with t raised to the power minus 8. As the exponent is negative, to make it positive, I have shifted in the numerator. This was the step which we have done in the previous slide. Now, what I need to do here, as the base is given to us like 5 raised to the power 3 is with us, can I write this 25 as 5 raised to the power 2 into 10 raised to the power 8 into 5 raised to the power 3 divided by t raised to the power 4 into this 10 can be written as 5 into 2. Now, what I need to do, I need to apply the laws of exponents to solve the further steps. It will be equal to, here the base is same, multiplication sign is there between all the terms, so exponents will be added. So I can write like this: 5 raised to the power 2 plus 3 into 10 raised to the power 8 divided by t raised to the power 4 into 5 into 2. Now I need to write the law of exponent, that is a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. We need to mention the laws of exponents which we are using. After this, what we are supposed to do, we need to solve this. It will be 5 raised to the power 5. 2 plus 3 is 5. Now, look at these two. Here also I can apply one of the law of exponent. That law is a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. That is, I am writing it. Now it will be clear to you like how we are supposed to do. It will be t raised to the power 8 minus 4. I am writing directly the result because I will be telling you the law after this step. It will be 5 into 2 again. Now here what I have done, I have applied the law of exponent, that is a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. This is m minus m. Now you can see both the laws, you can compare these. Here what is it? Base is same, base was same and they are being divided. You can see like this. This is the law. Base is same, exponents, these are being divided, so exponents will be subtracted. After this, it will be equal to 5 raised to the power 5. Here also this will be shifted in the numerator. Base is same and its exponent is 1, so they will be divided. So it will be 5 raised to the power 5 minus 1 into t raised to the power 4 divided by 2. So what it will be equal to? 5 raised to the power 4 into t raised to the power 4 divided by 2. Further, it will be equal to 625, that is 5 raised to the power 4 into t raised to the power 4 divided by 2. Here, in this step and here, the laws of exponents which I have applied, I am writing again here, that is a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. These are to be subtracted. Exponents get subtracted when they are having the same base and they are being divided. So I hope, dear children, you must have understood this 7th question first part. Second part you must have done yourself. Now I am going to discuss exercise 12.2, question number 4. Question number 4 is, in a stack there are 5 books, each of thickness 20 millimeter. So that is, I am solving it. I am doing the solution of this question number 4. I am reading the question first completely and then I will be solving it. The question is, in a stack there are 5 books, each of thickness 20 millimeter and 5 paper sheets, each of thickness 0.016 mm. What is the total thickness of the stack? We are supposed to find the total thickness of the stack. So I am doing the solution. Firstly, the thickness of one book is given to us, that is equal to 20 mm. Therefore, what will be the thickness of 5 books? The thickness of 5 books, what it will be equal to? 20 into 5, that will be 100 mm. This is what it is given to us in the equation. So we have calculated the thickness of 5 books because total number of books were 5. Now we have been given thickness of one sheet of paper. That is given to us as 0.016 mm. Now I will be finding the thickness of 5 sheets of paper. Thickness of 5 sheets of paper will be equal to 0.016 into 5, that will be equal to 0.08 millimeter. Now we are supposed to find the total thickness of the stack. So what we are supposed to do? We are supposed to add this and this. So we will be getting the total thickness of the stack. So thickness of stack equals, what was the thickness of 5 books? It was 100 mm plus thickness of 5 sheets of paper, it was 0.08 mm. So total will be 100.08 mm. So this will be the total thickness of the stack. It's time for homework now. Dear children, I hope you have understood all the topics of this chapter well. Now you are supposed to complete exercise 12.1 and 12.2 in your homework notebooks. If you have done these 2 exercises earlier, then you can revise your solutions or you can cross-check your solutions, as I have told you in this lecture also and the previous lectures also. So you can cross-check your solutions, or if you have not completed, complete these 2 exercises first. And along with these 2 exercises, I will be uploading one assignment on EdQuark under the homework column of this chapter number 12, Exponents and Powers. So you are supposed to complete that assignment also. So your homework is to complete exercise 12.1 and 12.2 in your homework notebooks, and one assignment I will be uploading on EdQuark site under the homework column that you are supposed to complete. So that's all for today. I hope, dear children, you have understood all the topics of this chapter. Thank you so much.